And in case that we have higher order differential equation that n is greater than 2, the one that n equal to 2, I just derived it for you. But now what if we have the differential equation which is the order of the equation higher than 2? That means we have to set the equation, right? And here is the way to set the equation. If the order 3, you would have V1, V2, and V3. So that means when you write down, you've got to find 3 different variables. That means you've got to build 3 different equations. If you have order 2, you're going to have parameters V1, V2, V3, and V4. So that means you've got to have 4 differential equations. And the way that we do how to set the equation is not difficult. Okay, if you have n equal to 3, the way that you do, if you observe the equation right here, you would see that every equation you have just the first derivative of your V1 and the first derivative of your V2. Any function, I mean, like if you have order 3 differential equation, that means you have V3. So whatever the parameters inside the equation is going to be the first derivative of V1, the first derivative of V2, and the first derivative of V3. All the equation would happen like that. And then for the y term, it starts from y. And then the first derivative and the second derivative and the last one is going to be n minus 1 derivative of y. Every equation equal to 0 except the last equation that is equal to fx divided by a0x. a0x is defined as the coefficient in front of the highest differential term in your equation. It's just the coefficient in front of the highest differential term in your differential equation. Just that. So only the last equation that's not equal to 0. It's equal to fx divided by a0x. Okay? But the rest, they are equal to 0. So if you have second derivative, you have 2 equations. If you have third order of differential equation, you got to be able to set 3 equations like that. Okay. Now take a look at the example. Find yp of this differential equation. Now, if you look at on the right hand side, you see sec x and times tan x. So from your previous method, can you use any technique to find yp? Can you use the first method to find yp? No, because the function here is not a UC function. Can you use operator technique? The first one we call what? Successive integrating. Can you use successive integrating? You can't, because here you got d squared plus 1. You can't make it in the term of d plus something times d plus minus something. You can't. They have I. Actually, you can do it like a d minus I times d plus I. But I is called imaginary part, so you just can't really integral that term. Okay? So Now it's only one way out that you can use is this method. Okay? From that, it said that you got to assume yp is equal to v1 y1 plus v2 y2. So v1, y1 and y2 is a function from your yc. So that means you have to know your yc first, right? Okay. Although the problem itself didn't ask you to find yc, but with this method you need to have yc because you want to know the function inside your yc in order to put into your yp, right? Because in yp you have y1 and y2. If you don't find yc, you don't know what is y1 and what is y2. So find yc, we got to write down the characteristic equation, which is n squared plus 1 equal to 0. So our m is equal to plus minus I. Our yc is what? C1 cos x plus C2 sin x. Okay, so then that means our y1 is cos x and our y2 is sin x. Now, for variation of parameters, you could set two equations because now you know that you have two unknowns that you need to find, which is y1 and y2. Okay, so we got to set two equations, and of course the first equation it would be equal to 0, and the second equation should be equal to 6x times 10x, right? A0x equal to 1, right? It's just the coefficient in front of the term of highest derivative in your equation. So in that case, let's set equation. Our equation is y1, the first derivative of v1 plus y2 times the first derivative of v2 equal to 0, and the first derivative of y1 times the first derivative of v1 plus the first derivative of y2 times the first derivative of v2 equal to fx divided by a0x. Fx is equal to 6x times 10x divided by 1. So I just put it right there. Okay. Now, to find v1, the first derivative of v1, you choose find the determinant of 0, 6x, 10x, and y2, and the first derivative of y2, y1, the first derivative of y1, y2, and the first derivative of y2. Now, we know that y1 is equal to cos x. So the first derivative of y1 equal to minus sin x. And we know y2 is equal to sin x. So the first derivative of y2 is equal to cos x. Now just plug in there, you would get So our first derivative of v1 is equal to, do the determinant, minus sine x times sec x times tan x divided by cos square x plus sine square x. Cos square x plus sine square x is equal to 1. So you would get minus sine x, sec x is equal to 1 over cos x times tan x. You would get minus tan square x. Then you got to do the integral of this term, right? Because we know that the first derivative of v1 is equal to dv1 by dx is equal to minus tan square x. So that means our v1 is equal to integral minus tan square x dx, okay, which is equal to x minus tan x. And now we find the first derivative of v2 by using differential rules again. So we got y1, the first derivative of y1, 0 sec x tan x. y1, the first derivative of y1, y2, the first derivative of y2. y1 is cos x minus sine x, 0 sec x tan x, cos x minus sine x, sine x cos x is equal to tan x. But we know that the first derivative of v2 is equal to dv2 by dx equal to tan x. From here we can find v2 is equal to integral tan x dx, which is equal to minus ln cos x. Now first we know that, we assume that our yp is equal to v1 y1 plus v2 y2. We just put our v1 in there, so we get x minus tan x times our y1, which is cos x, okay, and then minus our v2 is just minus sine ln cos x times y2 is a sine x.